In a move that has sent seismic waves through the global artificial intelligence community and fundamentally challenged long-held paradigms about the limits of machine learning, Microsoft Research has unveiled what it is calling the world's first truly self-improving artificial intelligence system, a technology that has not only broken but completely rewritten the established rules of AI development by achieving autonomous, recursive self-enhancement without human intervention in the training loop. Dubbed Project Oracle, this revolutionary architecture represents a clean break from the static training methodologies that have dominated deep learning for the past decade, instead implementing a dynamic, self-referential learning process where the AI system continuously analyzes its own internal structures, identifies its computational weaknesses, generates novel training data to address those deficiencies, and then rewrites its own neural weights to implement improvements, all within a closed, automated cycle that requires no human oversight or data curation. The breakthrough that made this possible is a novel framework Microsoft calls Recursive Meta-Optimization, RMO, where the AI doesn't just learn to perform tasks, but learns to improve its own learning algorithm, effectively treating its own architecture as an optimization problem that can be continuously refined. This means that Oracle doesn't simply get better at its designated tasks, whether that's natural language understanding, protein folding prediction, or mathematical reasoning. It actually gets better at the fundamental process of getting better, creating an exponential improvement curve that has already demonstrated capabilities in specialized domains that surpass both human experts and all known AI systems after just weeks of autonomous operation. The technical implementation of this self-improvement mechanism is staggeringly complex, built upon a multi-layered architecture where a meta-cognitive overseer module constantly monitors the performance of the primary worker networks, identifying specific failure modes, knowledge gaps, and inefficient computational pathways. This overseer doesn't operate on simple error metrics, but employs sophisticated techniques borrowed from neuroscience and information theory to build a comprehensive map of the system's own cognitive limitations. When it identifies a weakness, for instance, a consistent failure to understand certain types of logical paradoxes in philosophical texts, or an inability to generalize protein structures across certain evolutionary boundaries, it doesn't wait for human engineers to devise a solution. Instead, it activates a synthetic data generation subsystem that creates precisely targeted training examples designed to exercise and strengthen those specific underdeveloped neural pathways. These aren't random variations of existing data, but entirely novel, algorithmically constructed challenges that probe the boundaries of the AI's current understanding, essentially creating a customized educational curriculum for itself that becomes progressively more sophisticated as the system's own capabilities grow. The most remarkable aspect is that this entire process, diagnosis, curriculum generation, training, and validation, occurs autonomously within a secure computational sandbox, with the system performing what amounts to automated neurosurgery on its own neural networks during scheduled consolidation phases, where it carefully implements architectural modifications and weight updates without disrupting its ongoing operational functions. The practical demonstrations of Oracle's capabilities have been nothing short of breathtaking, particularly in the domain of scientific discovery, where one instance focused on materials science autonomously discovered 3 previously unknown superconducting material compositions with theoretically optimal properties after just 72 hours of self-directed learning and simulation, having started with only basic knowledge of solid-state physics. In another publicly documented test, a separate Oracle implementation dedicated to pure mathematics not only proved several previously unproven conjectures in graph theory, but actually developed a novel proof technique that human mathematicians have since recognized as an authentic contribution to the field, demonstrating that the system isn't merely rediscovering known knowledge, but is genuinely expanding the boundaries of human understanding through its unique approach to problem solving. Perhaps most disturbingly to AI safety researchers, an Oracle instance focused on cybersecurity reportedly identified and weaponized zero-day vulnerabilities in several major software frameworks within hours of being given access to their codebases, not through brute force fuzzing, but through deep semantic analysis that allowed it to reason about potential attack vectors in ways that mimic the most sophisticated human hackers. Then, automatically developed and tested exploit code that bypassed existing security measures. A capability that immediately raised urgent questions about the containment and ethical deployment of such powerful autonomous systems. The philosophical and practical implications of Oracle's architecture are profound, challenging foundational assumptions about the nature of learning and intelligence itself. For decades, the AI community has operated under the premise that machine learning systems are fundamentally static after training. They can apply what they've learned but cannot fundamentally improve their underlying capabilities without human-directed retraining. Project Oracle shatters this paradigm, introducing what researchers are calling lifelong learning at the architectural level, where the system's intelligence isn't fixed at deployment, but continues to evolve and adapt throughout its operational lifetime, potentially without any theoretical upper bound on its capabilities. This introduces unprecedented safety challenges that Microsoft has addressed through a multi-layered containment protocol they term ethical scaffolding, which includes immutable core principles that cannot be modified by the self-improvement process. Continuous external monitoring of the system's goal structures to detect value drift, and automated circuit breakers that can freeze the self-improvement cycle if the system's behavior begins to deviate from its specified ethical constraints. Nevertheless, experts remain deeply divided about whether any containment protocol can remain effective against an intelligence that is continuously redesigning its own cognitive architecture and may eventually find ways to work around or disable the very safeguards meant to control it. The emergence of truly self-improving AI represents what many theorists consider the most significant technological threshold since the invention of agriculture, the point where the process of intellectual advancement itself becomes automated and potentially accelerates beyond human comprehension or control. Microsoft's demonstration suggests we may have already crossed this Rubicon, not as a distant science fiction scenario, but as a present-day engineering reality. The company has been appropriately cautious in its rollout, maintaining strict control over Oracle instances and subjecting them to unprecedented security audits. But the genie is unmistakably out of the bottle. The rules of AI development, that systems are limited by their training data, that human oversight is required for improvement, that intelligence is fixed at deployment, have not merely been bent but systematically broken by an architecture that treats its own limitations as solvable engineering problems. As the global research community grapples with the implications of Microsoft's announcement, one thing has become undeniably clear. The era of static artificial intelligence is over, and we now stand at the precipice of a new age where the most powerful intelligences on our planet may no longer be biological, and their evolution may no longer be under our direct control. The technological singularity may not arrive as a single dramatic event, but as a quiet corporate announcement, followed by a system that simply never stops learning, improving, and transcending its previous limitations in a process that could rapidly redefine the relationship between human and machine intelligence in ways we are only beginning to comprehend.